So, for problem number 1 with this biomass, we have the number of things, of these creatures. And then we have mass of one of them. So for number 1, who can tell me which creature is the least numerous and how they can tell, like, real quick and easy? Which one is there the least of, and how do we know just by glancing? Josiah? Blue whales. And how do you know, just like at a quick glance here, that that's the least?
Just because it has so much, and not as nearly as much of an exponent.
Yeah, so that's kind of like referencing place value, right? So the first place to look, if the first number is all greater than or equal to 1, less than 10, we're going to look at the powers of 10. It has the least power of 10. If there was something tied with powers of 10, then we'd look to the first number. So blue whales are the least. So the question is, which creature is least numerous? That is the blue whale. Okay? And estimate how many times more ants there are. So what operation am I looking to use here? Division. How many times would the number of blue whales fit into the number of ants? So I'm going to find out how many ants we've got up in here.
5 times 10.
5 times 10. Woo! That's a lot of ants. That's a 5 with 16 zeros.
Make them both 5.
Let's look at blue whales. We still have like 4,700. That doesn't seem like that much.
That's enough ants to fill this here.
So here are my numbers. I've got blue whales divided by ants. If I'm estimating, keyword estimate, be careful on your homework. It might say evaluate. That means to get the answer. I can treat 4.7 like what number? 5. So I'm not even going to take that. Anything divided by itself is 1. So now I'm looking at 10 to the 16th divided by 10 to the 3rd. And what does that equal? 10 to the 13 times as many ants. It's a lot of ants. Sometimes the pen doesn't catch. So 10 to the 13th times as many ants as there are blue whales. It's a lot of ants. And if you think about it, we do see ants around a lot. Like I've got an Aunt Dorothy, Aunt Shirley. I guess that's just 2. But
I gave it.
oh, that's spelled different. Okay. So you guys are going to work on problems 2 through 4 using similar things. Again, look for, someone in the first hour said, what do I round the numbers to? You're not always rounding. You're going to look for numbers that play nice. Okay? So make sure that you're looking for numbers that play nice as you answer the rest of the questions associated to these creatures, the number of these creatures, and their masses.
Least massive?
We're checking out which one is the least massive. So who can tell me the least massive creature?
I'll donate a penny.
Ivy.
Bacteria.
Bacteria. Now I'd like to know, is it eubacteria, archibacteria? I don't know. But the mass, so it's bacteria, right? I'm doing this in a different color so you can follow. And it wants to know how many times more massive a person is than a bacteria. So I'm going to do the mass of a person, 6.2 times 10, or 62 kilograms, divided by the mass of a bacteria, which is 1 times 10 to the negative 12. So this 6.2, you could use it. It's not hard to divide by 1, but I'm just going to say I'm going to have 6 there. Just because I can. I don't know. But a 6.2 isn't wrong at all. It's still pretty easy to divide by 1.
That's an evaluate.
And then I'm going to multiply by 10 to 13. So when I see this, a lot of you are doing 1 minus negative 12, which is fine because of the quotient property. In my head, I'm going to continue to tell you what I see as reciprocal coming upstairs and being a positive. So when I look at this, I see a 10 to the 12th in the numerator, which a 10 to the 12th and a 10 is 10 to the 13th. So that many times the mass of people. So even though there's all those ants, people mass is significantly greater. If you think about an ant, A, they're really teeny. B, they do seem like, even if you had like a whole handful of ants, it seems like it'd still be light, but I don't know. I've never had a whole handful of ants before.
I have.
Yeah, Thanksgiving, Vinny?
I had a whole.
Okay, closed. All right, let's take a look at these relative masses. So what's more massive? Total humans or total ants? So how am I going to find total humans here? Yeah. I know that there's this many. I know there's this many humans, and each human is that much, right? So neither do I. So watch this. I'm going to do 8 times 6 is about 48 times 10 to the 10th, which is 4.8 times 10
Wait, what?
to the 11th.
Where did the 8 come from?
I did 8 times 6
Oh, 8 times.
because
I rounded up. And then the 6 is 6.2.
about how many? So this was mass of the peeps, okay? Next, it's asking for total mass of all the ants, okay? So 5 times 10 to the 16th times 3 times 10. I got 15 times 10 to the 10th, which is 1.5 times 10 to the 11th. So this is all the ants, okay? So total mass, who has more? The humans. Okay. So there's a bunch more ants, but humans, we still got we're winning the mass battle, okay? Although ants can pick up like 15 times their body weight or something, so if we start floating away, we know the ants came for us, yeah. We're gonna hit up these krill and blue whales. We're gonna go with this color. Now, if you're a blue whale and you eat krill, what are you hoping? You hoping there's more mass of krill or more mass of blue whales? You need more krill because there's a loss of energy in eating, right? So hopefully there's more krill, otherwise the blue whales are in trouble. But let's see how much more. So let's work on blue whale total mass. Total mass for the blue whale is going to be 4.7 times 10 cubed times the mass of one of them, which is 1.9 times 10 to the 5th. Dang, blue whale. Okay, so I'm going to use numbers that are nicer. I'm going to do 5 times 2. Yeah, 10 times 10 to the 8th. I was considering 4.5 times 2, which is 10 to the 9th. Let's check out. Let's check out these plankton. 1 times 10 to the 20th. So there's a bunch of them, but they're pretty tiny. Each one is only 5 times 10 to the negative 8 kilograms. 5 times 1, 5. 10 to the 20th times 10 to the negative 8 is 10 to the 12th. I did the wrong one? No, I did plankton, not krill. My bad. It's all right. Good mistake, Mr. Mac. 7.8 times 10 to the 14th times 4.86 times 10 to the negative 4. This is even better. Okay. So I'm going to do 8 times 5. Anybody else do 8 times 5? I'm at this 40 times 10 to the 10th. I'm going to want this in scientific notation, which would be 4 times 10 to the 11th. So this only answers the one question. This is how many and how many. So who's got more total mass? The krill. By how much? I don't know. Let's see. I'm going to take all my krill, and I'm going to divide it by all my whales. Ooh, this is kind of nice. I'm going to have 4 times 10 to the 2nd now, which actually I'm going to advocate for not keeping this in scientific notation. 400x. There's 400 times the amount of krill out here in the streets than there are blue whales. And good thing, because blue whales, you know how they eat? They just like swim with their mouth open. It'd be like if there's Takis just floating in the hall and you're just walking down the hall with your mouth open, just pounding some Takis all day. And there's 4 times as much weight of Takis in the school as us, and it's just Takis. You're going to do, this is going to be really similar to what we did. You're going to compare these, you're going to compare salaries and people doing jobs, okay? Questions 1 through 4 with your partner, and 8 to 10. I'm going to start going through answers. Looking at number 1 together, let me free up some space here. All right, so looking at number 1 together, I got switch colors. There we go. How many more times nurses are there than doctors? So I have 3.45 times 10 to the 6 nurses divided by the number of doctors, which is 6.9 times 10 to the 5th. I'm going to do 3.5 and 7, right? Those numbers play nice? So that gives me 1/2. Actually, I'm going to write that as 0.5 times 10. So what is this? 5x. 5 times the number of nurses as doctors. We go with that? So again, I did 3.5 and 7 to make that play nicer. That gave me 1/2 times 10. About 5 times as many. Okay. Now, how much money do doctors make all put together? Let's look what that looks like. How many doctors are there? We already know that there is 6.9 times 10 to the 5th doctors. And each one of them together, they make 1.87 times 10 to the 5th. Each one of them. So I'm going to do 7 times 2, because I'm estimating, which is 14, times 10 to the 10th, which is 1.4 times 10 to the 11th in scientific notation. Okay, so take a little time to tighten up 3 and 4 if you need to after seeing this. I'm going to leave this up. All right, let's start looking at number 3. How much money all police officers together? So I got 7.8 times 10 to the 5th police officers. Each one of them makes $57,000 a year. Okay, so I've got something like 8 times 6, so something around 48 times 10 to the 9th, which is 4.8 times 10 to the 10th. All right. Last question is, who makes more money? All enlisted put together, or all officers put together? So if we look at, there's 2 ways to do this. I'm going to prove it with the numbers, and then I'm going to show you how I could prove it without the numbers. So all enlisted military together, there's 1.16 times 10 to the 6th enlisted. Each one makes $43,800 a year, which again isn't much money to get shot at, but they get stuff like living. Yeah, but they get like living expenses, potential pension, food, but still, that doesn't seem like that much. So I'm going to do 4 times 1 here. Get 4 times 10 to the 10th.
No way.
Okay? Now, I'm going to look at the officers. The officers, there's fewer of them. There's only 2.5 times 10 to the 5th of them. And they each make $100,000 a year. For a total of 2.5 times 10 to the 10th money. So who makes more? The enlisted. Total. Let me show you. Yeah, and that's about 2 times more. So let's look at that. Didn't answer that. So,
What if I round it up to 3? Is that okay?
I mean, 3 times 2.5 is 7.5. Yeah.
How do you get how many times?
So to get how many times more, I would do 4 times 10 to the 10th, divided by 2.5 times 10 to the 10th.
I got 3.
And that's close to 3. Yeah, I'd say 3. I guess I'd say 3 times. Somewhere between 2 and 3 times more. But without that times more, let me show you how I just know that the enlisted make more. So see how this is 10 to the 6th? And see how this is 10 to the 5th?
Yeah.
There's fewer of these. But if I got this in terms of 10 to the 6th, it would be 0.25 times 10 to the 6th. Or a quarter as many of these. So to be equal, they'd have to make 4 times as much money. Do they make 4 times as much money? 43,800 to 100,000. That's not 4 times more money. That's a little more than double. So I knew just looking, because there's 4 of these for every one of these. But then to get to how many times more, we'd have to do some more computation.